All right, so it was about 2002 or so when we put the A in MERRA for applications. And in that time, I'm really pleased to see this workshop. I don't consider it, say, a prediction of what was going to come, but we proposed this, and the applications examples we had proposed were water management and water quality. And as Laura so graciously reminded us how the first MERRA does in its precipitation, yeah, it didn't go exactly as planned, but this session's really wonderful to see. I don't have necessarily an agency hat to wear, but NASA is talking a bit more about applications and reorganizing the strategy for applications into what's called NASA's Earth Action Strategy. So it starts on the bottom of this pyramid with all the satellites that we put into the orbit. And then I see the GMAO as sitting in this Earth System Science Tools for Impact, research, analysis, modeling. And one thing that I don't necessarily like about this diagram is sort of the vacuums that they have set in between the different layers. So what I'm going to do today is talk about the people that I've been working with lately who sort of reside in between within this little vacuum here. And part of me wants to redesign this pyramid to have the pathways to get up and down through this. So I started thinking about it as the kids' game Chutes and Ladders, and that in and of itself there probably says why I don't have an agency hat. But we need ways to go up into the action solutions, and we need ways to get the information back from them. It's sort of built into this diagram in what they're calling the virtuous cycle, and that's this arrow right down here which brings things back around. Okay, so that's going to be the theme for the next few slides. As Arun just showed you the WMO climate reanalyses, and one thing that was put to us, I'm not sure how clear it was, but there's a list of mandatory data that we have to be able to produce and provide. So when I took this request to our data center, the Goddard Earth Science Data and Information Services Center, laid everything out for them. They've had this tool around for quite some time, maybe more than 20 years, is Giovanni. And within 2 weeks, they built a portal for this data. It has all the mandatory variables. You can do some various statistics here if you pull this down. You can select your date range, you can select your space, however you want to do it, and any number of variables. You can make plots and download the data, and this was all stood up within 2 weeks. Really, our data center is really our biggest interface into the user community, and they do a really fantastic job for us. One of the other things they've done recently is started using tools to go out to Google Scholar, searching for the DOIs for our data and also the alphanumeric short names that we use within the data center. And when they find those references, then they're building this database and categorizing them as to the topic of how they're being used. And so you can go in and search this and find, say, recent air quality articles. You can find even earthquakes, which I haven't done yet, but I really want to try and look and see how MERRA 2 is being used in earthquakes. Some of the use cases that are using MERRA 2, artificial intelligence for 1-hour solar ultraviolet index prediction, basically for skin protection. They are also, and this was somewhat compelling, is photovoltaic performance. And they're using the PM 2.5 and PM 10 coming out of MERRA's interactive aerosols. And that's dust landing on the solar cells that is going to affect the performance. Water management, actually, but they're not using the precipitation. They do use the surface meteorology. And somewhat science fiction-y to me is testing the flight paths for medical drones in an urban environment as compared to their ground-based routes and going through traffic. That was an eye-opener for me. That all comes out of our data center. I'm not going to say too much about wind energy. We've heard a lot about it already today. Early on in the development of MERRA, we added in the 50-meter winds, and I was hearing stories about uptake in Europe but not really given any good use case examples. And then in 2016, we turned MERRA off. And the American Wind Energy Association came to us and actually offered to pay us to continue the first MERRA. We graciously declined and explained to them that MERRA 2 was better and they should start using that. I also want to acknowledge Remy's talk earlier and the workshop he had earlier this year. It was a really good way to connect with this community. Another way we get the data out into applied users is our collaborations with Paul Stackhouse and his project called POWER, the prediction of worldwide energy resources. And so this has been going on since, I think, before the first MERRA. They bring the data in, put it into user-friendly formats for the energy community. One example is they have a GIS reformatting portal. Some of the use cases that they have is this produced water ecoservices, where they're actually developing systems to treat and return water back into the system. And then TerraSmart and Argonne National Labs are also developing solar projects, generally using MERRA's meteorology. One of the other things they've done is develop these building code indices. And the people who make the buildings use this to decide their heating and air conditioning and also insulation standards that go into buildings. Then this chart right here is they're demonstrating to this user community where those building codes are changing. Red indicates they're moving to a warmer building code, and the blues, very few of them there in the Rocky Mountains, are moving towards cooler building codes. What they also do is provide the users with evaluations of the surface meteorology from MERRA that they're getting. So in the Taylor diagrams here for hourly and daily, this lets them put relative all the different variables. If it's probably not too legible there, but the three outliers that you see here and here is precipitation, wind speed, and the maximum wind speed. So those are presumably the ones we need either to work on better, or there's just so much variance within the local scale of a station compared to the grid box of MERRA that it's very difficult to get good correlations to. Now, we're also working with them to get MERRA 21C into this system when it's ready. I'm hoping before that they'll be doing some of this meteorological evaluation with us as well as we document the system. They also provide a visualizer for the energy community. This particular chart is MERRA 2's daily wind at a wind farm off the coast of Denmark. Now, in the past year, we were contacted by the U.S. Department of Treasury, Office of Financial Research, just asking about the data, some technical questions about the data. So I answered their questions and went back to them to find out what they were doing. And it turns out they are obligated to do some financial risk due to climate. And the interesting thing is where I've found the wind energy community to be very savvy about the reanalyses data. The Office of Financial Research had absolutely nobody working on climate in their system. So what Stephanie Scholar-Ooze, who's the lead for the Goddard Applications Group, set up a pilot project, and we worked a case study with them. In this case, it's Hurricane Harvey. And on the left, you see MERRA 2's precipitation aggregated to county levels, and the total individual and household program claims by county that occurred because of this event. And then this next chart is the maximum wind speeds that were recorded during the event and compared to the claims that, for destroyed properties. And they found, the Office of Financial Research found some very nice correlations. Their original request for us was something down to the kilometer scale or better. They would really like to have household scale. So we're not quite there yet, and even going to county level was a stretch for MERRA 2, but this was a pilot project, and we're hoping some of our newer, higher resolution data will be much more useful for them. Something that we do in the GMAO is a visualizer called Fluid, the framework for live user invoked data. One of the very cool things we set up there first was 3-hour weather maps. So you can go in there and pick any time in the past 40-odd years of MERRA 2 and make a weather map anywhere over the globe. We've also put there maps of the monthly data and their anomalies and some other statistics. What's shown here is the precipitation for days exceeding the 95th percentile. Happens to be September 2004, and some of those deep blues and purples there are related to Hurricane Helene and the tragic devastation that occurred in western North Carolina. On the left, there's a link there for the data access to some of our extreme diagnostics, and on the right is a link to the visualizer. On the inside, we are interested in doing some work on climate diagnostics. For example, Alex Rain at NASA GISS developed a list of climate impact drivers. If you haven't seen this, I recommend it. It's a very practical list of indices. And some of those are the date of the last spring freeze and the date of the first fall freeze. And we're taking a look at these right now in MERRA 2. These maps in particular are the trends. So what you see is the last spring freeze is happening earlier in the year over much of the US, while the first fall freeze is happening later. A lot of this is in the global warming signal. We've been testing it against the ENSO and PNA and other modes, but the East Pacific and North Pacific seem to be the biggest drivers for east of the Rockies. We've heard a bit about MERRA 2. Really what I want to call out here is things we're building in for people who really want to get into the human dimension. There's the Fire Weather Index. And I want to make real quick a mention here for the MERRA 21C Polar. This is essentially a dynamic downscaling, a replay to MERRA 21C. And we're targeting 7 kilometers for that. And so we're going to piggyback off of this project and save a few variables, especially the surface meteorology, that should be useful for applications. The boundary layer height collection we've heard of, boundary layer height levels collection we've heard a bit. I wanted to include this here so you can see which variables are written out on the constant height levels, as well as the list of constant levels you see there. This figure is 1 day off the coast of Denmark, by the way, where you're seeing the evolution of the mixed layer in the black lines and some clouds and the winds. Amin Desfouli is giving a PowerPoint, a poster today. I recommend you go take a look at that. And I want to make this summary real quick. There's probably too many applications out there that I can even keep track of. And it's because when we get into this database, how do we, there was so many of them, I couldn't believe it. So questions that I have for the community is, what are we doing that's missing? What can we do to improve that? And we heard some things this morning, like the 15-minute data. We have very good systems engineers. If we put these requests to them, we can try to answer them. We may not be able to do all of them. I think this is a great session to have, but if you look at all these things, what can we do that's more? And I'm wondering if a whole conference on the applied uses of reanalyses isn't in order, and try to do more things, as Remy was showing, is this kind of face-to-face connection with the users community. And I just about used up all my time. Thank you very much.